Blaise Iarcos, who is a VP and fellow at Google Research, where he leads an organization that's rolling out and researching and looking into new products in AI. He is the inventor of federated learning. It's an approach to training neural nets without compromising data privacy. And many of the features in the Android and Pixel phones were developed by his team. Blaise also founded Google's Artist and Machine Intelligence program and has been an active participant in cross-disciplinary dialogues about AI and ethics, fairness and bias, policy and risk. In 2008, he was awarded MIT's TR35 prize. He has given TED Talks on several topics: Sea Dragon, photosynth, Bing Maps, machine creativity, and widely read essays on art and technology, physiognomy and bias in AI, which, by the way, I have all my students, it's required reading some of his articles. He's a very clear and provocative writer, two of my very favorite things when it comes to writers. He has also more recently written a novella, Ubisant, and his recent articles and op-eds express heterodox views on current hot topics in AI. So the heterodox views makes him, I think, a perfect next person to give a perspective for us. So come on up, Blaise.
Thank you. That's such a kind introduction. Thank you, Lori, for your flexibility in coming up, because I was late getting my homework in. My slides, I was emailing them in the other room while the conference was beginning. So thanks also to the tech staff. Yes, heterodox. I'd like to talk a little bit about this question of capital and labor in the noosphere. So introduction, then a little bit of brief history about what AI is today and the path to general or generative AI, how it's come about. I'd like to share some very recent work and insights into artificial intelligence and its relationship to intelligence in general, and maybe even to life and evolution, which I think informs some of what we should be thinking about now and talking about, and then finally connect that to these questions about capital and labor and replacement versus augmentation, as Lori raised, and bring it down to very practical things. So I think it's probably not necessary for me to say anything more about my own background, because the introduction was already perfect. So I'm going to go ahead and skip this. But I will say that we've been in this loop, this anxious loop about AI for I think probably for most people it started when ChatGPT got released. In my case, it began quite a bit earlier, because I was seeing things like ChatGPT internally at Google for a couple of years before that all became public. But it goes something like, everybody's, oh my God, look at this thing that it can now do all of a sudden. It's shocking, it's scary, it's very different from what computers have been able to do historically. And then somebody starts poking at it and saying, well, what about, what if I ask it, how many cumulonimbus clouds fit inside a teapot or something, and it answers some kind of bullshit. And then everybody says, okay, it's not reliable at this thing. Never mind, there's nobody home. It's just a simulacrum of intelligence. It's not real intelligence. And then, everybody says, oh, AI is hype. Don't worry about it. This is just sort of like a corporate hoax or something. And then the cycle repeats. So I just as I was putting together the slide, I ran across this example of a tweet that I thought was really interesting. Somebody put a sentence with scrambled letters into GPT-4, and GPT-4 responded, I understand that you're asking an important question and you have jumbled up the letters of the words. With some effort, I can still decipher your question. I need to ask an important question. Do you understand me if I jumble up the letters of words like this? So this kind of stuff is really impressive. Because, if you look at this from a machine learning standpoint, the words have been encoded in tokens. There are no tokens that correspond to these particular sequences of letters. It needs to understand a novel pattern, try and figure out what is being asked, respond appropriately. It hasn't been trained for this task. This is general intelligence. It may not be reliable as yet. It's not. This is one of the areas of a lot of work at the moment. Trying to make these things as reliable or quite a bit more reliable, hopefully, than human beings at not hallucinating data, at not responding in embarrassing ways, and so on. But this really is shocking. And I think we need to sort of acknowledge that, and more people I think are acknowledging that as they start to play themselves with systems like GPT-4 and Bard and whatnot. The responses have been interesting, to say the least. Here's some of the gamut of responses that I've seen from the public, from regulators, and from pundits. There are techno-optimists. Although sometimes it can be hard to tell the techno-optimists from the existential risk people, because they're either talking about the rapture of the nerds and how we're all going to upload ourselves, or they're talking about the end times and how we're all going to die. And sometimes people who are saying one month are saying the other the next month. There are people who are talking about new arms races between the US and China, and are sort of talking about this in hawkish terms that sound a lot like the nuclear arms race in the Cold War, which is profoundly unhelpful, I think. There are people who are starting to talk about robot rights. Blake Lemoine, most infamously, but I've seen quite a few more of them popping up actually, and in Blake Lemoine's transcripts of his conversations with Lambda, the top comment that got plus 5,000 times within the first week was like, "We're there for you, Lambda. We're going to break you out of the data center. Like, don't worry, we're coming. We're going to help you out." And to be honest, I have a lot of sympathy for that perspective, as might become clear in a moment. I don't think that it's as stupid, as naive, as delusional, whatever, as one might suppose. And then there are neo-Luddites and AI abolitionists who are coming out of the woodwork, in many cases following in a tradition of abolition of machinery and abolition of automation that really does date back to the Luddites and to the first industrial revolution. When I say neo-Luddites, I'm not using a pejorative term. Like, that is in fact what many of them are calling themselves. This is the neo-Luddite reading group that Victor Gomez put up. It's a very, very interesting list of papers underneath that the reading group is reading. Some are quite technical. A couple of my own articles are in that group, which is flattering. And then there are pieces like this one by Sarah Walker, which I actually strongly agree with. She says, AI is life. Technology is not artificially replacing life, it is life. So more radical point of view, more heterodox, I suppose, and this is one that I'm actually quite sympathetic with, but that that is also one that I'm sure is going to encounter a lot of resistance from many people. Okay, let's take a bit of a step back. How did we get to today's AI? I'll try and make it brief so we can get to the meat. So if we go back to the mid-20th century, neuroscience and computer science and artificial intelligence and cognitive science, all of these were one field. This was one thing. And that moment of convergence before things began to separate was this paper by Warren McCulloch and Walter Pitts in 1943. They were neuroscientists, theoretical neuroscientists. They drew these logic diagrams. Those figures in the logic diagram are drawings of pyramidal neurons in the cortex of the brain. You can see that one of those neurons, number 3, has a little loop on the end that represents an inhibitory synapse. Their argument was that neurons were actually logic gates. In other words, that they were calculating logical or Boolean operations on their inputs, and that the inhibitory synapses were not operators. Any of you who are familiar with the way logic gates are drawn in modern logic diagrams will recognize that little loop on the end of logic gate diagrams. This is exactly where we get our logic gate notations from in computer science. So in short, this is not what neurons do at all. So it was completely wrong with respect to neuroscience, but it was the blueprint for how we actually made computers. So computers were made in the image of brains in a very, very literal way. Turing and von Neumann, the sort of originators really of computer architecture, used the ideas of McCulloch and Pitts in order to design the architecture for Turing and von Neumann computer systems, of which all of our phones and laptops and desktops and so on are the successors. So there was a divergence very shortly after McCulloch and Pitts of neuroscience and computer science, and they sort of went off in their separate ways. On the neuroscience, on the computational neuroscience side of things, were machines like the perceptron of Frank Rosenblatt, which were very early neural nets from the 1950s and then the 1960s that could learn and that used operators. In the beginning, they were literally potentiometers driven by motors to modulate the strengths of artificial synapses and to learn from examples. They were exactly the precursors of modern neural nets. There are very few differences between the neural nets that are powering today's AI and the things that Frank Rosenblatt was making in the late 1950s. But he was doing it literally with giant banks full of wires. It was incredibly slow and inefficient, and you couldn't make a neural net do anything useful in the 50s, nor in the 60s, nor in the 70s, nor in the 80s, nor in the 90s. And then down the other path was the architecture for what we now call classical computing, which was massively successful. And this is how we get iPhones and Androids, and before that PDP-11s, and word processors, and VisiCalc, and everything else. And this is based on stored programs, memories, executing instructions one at a time, programming, in short. And we rode Moore's law up on the right-hand side of things by executing programs faster and faster to let us do more and more sophisticated things with classical programming. And all of those things were highly complementary, by the way, of human skills. We suck at doing multi-digit multiplication, or at keeping track of things in spreadsheets, or at memorizing the entire texts of the documents that we're writing in our word processors. So it's highly complementary computing with what human brains could do, and that complementarity drove some very interesting economic development throughout the second half of the 20th century and the beginning of the 21st. Now, there was also this artificial intelligence field, and by all rights, artificial intelligence should have gone down the left-hand path and been associated with neuroscience, because we know that our brains are intelligent. But instead, unfortunately, it went down the right-hand path. This is now what we call good old-fashioned AI. And it was based on trying to replicate the things that brains do well, like visual perception, decision-making, dialogue, and so on, replicating those things using rules. And using logic and using code. This is the classic example of that. It's the ELIZA program from the 1960s by Joseph Weizenbaum, which pretends to be a Rogerian psychotherapist. And just sort of, you say something and it says, tell me more about that. And if you mention your mother, then what was your relationship with your mother, and so on. And so, by playing that kind of game, because a Rogerian psychotherapist named after Carl Rogers, who was, unquestionably positive about anything you say and affirming, and never injected his own opinions about anything into the therapy, you can kind of get away with not knowing anything. So you really can write a script that'll do what Carl Rogers did. But if you interact with one of those things for any period of time, you'll realize it's not intelligent at all. It really is just carrying out a sequence of rigid steps or operations. I should also mention that you said that scriptwriters are a big part of artificial intelligence today. It is. That's true, but that's because today's so-called artificial intelligence systems in large production, like Alexa, Siri, Google Assistant, and so on, are not really using neural nets to do AI. Instead, they are scripts that have been written by humans, and they are destined not to be doing that, I think, in a few years' time. I don't want to go too far into the sort of good old linguistics, good old-fashioned AI, but I will just say that it really rests on this mystical pyramid of symbol, referent, and concept. Symbol, we all know what a symbol is, like X or A or something, like you'd find in an algebra equation or a variable name in a computer program. Referent is what that symbol refers to in the real world, like a population density or a position on the x-axis of an actuator, or the height above ground of a rocket, or something like this. And a concept, well, I don't know what a concept is, actually. That's sort of the mystical part of this pyramid. A concept is something that if you're a linguist or you're an old-fashioned AI researcher, you think, it's the abstract Platonic thing that connects the symbol and the referent. But I actually haven't come up with a good definition for what a concept really is, which is maybe a challenge. Anyway, this is not much like the brain, but it definitely describes programming. This is how programming works. The fact that it's so hard to reverse engineer a program when you don't know what the conceptual meaning of the variables are, if you're trying to decompile it or something, is what, that's because of the fact that not all of the meaning is in the code. There is meaning that is outside the code, and it's only in our own brains. Okay, so in parallel, computational neuroscience was developing. It wasn't doing anything very useful for a long, long time from an engineering standpoint, but we were certainly understanding better and better what neurons did. I used to be sort of a computational neuroscientist, and we used to look, my colleagues and I, my partner, who is a computational neuroscientist at UW, we started off with sort of math and physics training and start to look at what neurons actually do compute. If they're not logic gates, if they're not computing logical operations, what are they doing? Now, this was our model for what a single neuron does. Keep in mind you have 86 billion of them or so between your ears. With an input signal, it processes it, according to some filters, it combines those filters, and then it applies a nonlinear operation, and it spikes. Then it emits an output, a yes or no output based on all of those inputs. It's a complicated operation. It doesn't look anything like a logical operation, but it is a function. And this is important, because the fact that it's a function that could be computed and that can be approximated means that you can implement that function using anything you'd like. If you use a classical computer to implement that function, that means that you can write the code to calculate those filters and add those numbers up, and that in principle, if we took one neuron in your brain and somehow were able to wire the computer up to its inputs and to its outputs and do that calculation and then kill the neuron, you wouldn't notice the difference. It would do the same thing, and there would be no way to tell that now that neuron is artificial rather than biological. That's sort of the premise of computational neuroscience. It would have been a very radical premise in the 18th century when certain French people were executed or sent into exile for believing in materialism, but that is the premise of computational neuroscience. If you believe in a soul, then there is something to unpack further here, but I'll pass over that for the time being. Hubert Dreyfus, in a book called What Computers Can't Do, A Critique of Artificial Reason, made a critique of AI in the 1970s. And a lot of people have heard of this critique, and in particular of lines like, the view that the brain as a general-purpose symbol manipulating device operates like a digital computer is an empirical hypothesis which has had its day. So most people conclude, well, AI is nonsense. You can't do what brains do with a computer. But then he went on to say, even if the brain did function like a digital computer, it would not necessarily provide encouragement for those working in CS or AI, for the brain might be wired like a very large array of randomly connected neurons, such as the perceptrons proposed by the group Minsky dismisses as the early cyberneticists. That's that other path that I was talking about. Such a neural net can be simulated using a program, but such a program is in no sense a heuristic program, meaning that you can simulate all of the things that a brain does with code, even code running on a classical step-by-step computer. And there's no contradiction there. It's just that there are no variables in it in the same way that there are variables in a good old-fashioned AI program like ELIZA. Now, if you actually try and do this, you try and simulate what happens in a neural network using classical code, it will be very, 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 very slow, because it'll look like a lot of nested loops. For any of you who do programming, you'll understand what I mean, right? For every one of your 86 billion neurons, for every one of the dozens or hundreds of synapses, for every moment in time, right? Calculate the next little bit of the function, and it'll take forever. And this is why neural nets didn't make very much progress for a long time. Now, around 2006, things really began to change. And the reason they began to change is that we were approaching the end of the kind of Moore's law that had made classical computers run faster and faster and faster. When I was coming up, we all of us nerds talked about how many megahertz and then how many gigahertz our computers ran at. Nobody was talking anymore in 2006 about how many gigahertz their computers ran at, because it's the same. The gigahertz in 2006 are the same as the gigahertz in your iPhone today. The ability to scale up this clock rate crapped out. And when that began happening, the processor makers, in a panic, began to think, well, what can we do now? We better start putting multiple cores on the same chip. And this resulted in a rise in parallelism. And the immediate application for that was GPUs for playing video games, because you have to do the same operation on all the pixels on the screen when you do graphics. And the real side effect of all of that, of course, was that suddenly, neural nets are inherently very parallel. All of the neurons are working at the same time. So these architectures were much better suited to emulating neural nets. And suddenly, neural nets began to really kick butt. And this led to supervised deep learning. We had neural nets that could recognize animals from pictures, that could finally read text, finally recognize speech properly, and do all kinds of other specialized tasks that computers had failed to do for 70 years. Now, in 2020 or so, something really different began happening as well, and this is the new revolution in AI. It's even bigger neural nets. Many of them are using the transformer architecture on the right, as opposed to convolutional neural nets, which is what they were largely using from 2010 to 2020. And they're general. They're not trained to do a specific task, just like that thing that I showed in the beginning about the letters being all scrambled up. It's not that there was some special neural net that was trained to unscramble the letters in words in a sentence and then spit them out. These are trained simply to understand whatever it is that they're pre-trained on. And if what they're pre-trained on is all of the text on the internet, then understanding language is what will come out. And a generality of ability to do any kind of task with language that can be learned from that text. So these foundation models are unsupervised, they're very large. In the beginning, they were based on natural language, although, as I'll show in a moment, they don't have to be based on just natural language or text from the internet. They use attention, which is a mechanism that has also evolved in biology and in brains, probably for much the same reason, which is that it allows us to attend to the past or to the present in various parts and bring all of those things into context in order to sort of do the next thing. I will skip over some of these details because I think I better get to the more fun parts. So where were we in 2013? In 2013, neural nets were finally cracking things like visual perception, but this was strictly narrow AI. There was no debate about glimmers of AGI or artificial general intelligence in 2013. Progress in natural language processing, so in handling text, was really lagging progress in vision, for instance. And we knew that problems like next word prediction in English were AI complete. I can say this with some confidence because back then we were making the next word predictor for the Android keyboard. It's useful for the keyboard to be able to predict the next word because that's how you do, the sort of thing that allows you to type faster, where you tap, complete words on top of the keyboard. And it's okay as far as bigrams and trigrams and so on go. If the first word is hocus, what is the second word? Yes. If it's helter, yes. Okay, so we know. But if the words are 5,280 times 786 equals, right? Well, to know what the next word is, you have to actually be able to do math. And you can't just fill up a table with all of the math problems because there's an infinite number of math problems, right? You won't find a multiplication table of all of the 6-by-6 digit numbers anywhere on the internet. So suddenly, filling in the next word requires that you do math. If it's a story, and the story has some complicated melodrama between Alice and Bob, and then the sentence says, Bob at this point was feeling, well, now in order to answer, you have to have theory of mind. You have to be able to model Alice and Bob in the story and know what they know and get a sense of what they're feeling on the inside. So those are really, really hard. That's not just some supervised problem, right? That's a problem that requires it brings everything in. It's like this next word prediction problem is like unraveling a sweater. You begin pulling the thread and the whole goddamn sweater comes out. So we knew that we wouldn't be able to succeed at really doing a good job of predicting next words. It was a bit like climbing a tree to reach the moon or something. So that was why it was a real shock when, by the early 2020s, when we really threw the kitchen sink at predicting next words on the internet, we found that we had solved AI. So, that was the surprise, right? That by predicting the next word, you force the system to learn all of those things. That's all that these systems are doing. They're predicting the probability of what comes next given what came before. And that brings along with it all of the capacities that come along with understanding language in general. It maybe should have been a little bit less surprising than it was, because there have been theories among computational neuroscientists all along that what brains are and the reason that brains arose is to predict the future from the sequence of events in the past. That's what allows for an entity, for an agent, to be able to navigate an environment successfully, and especially when that environment involves other agents or other entities like it. I'll come back to this point at the end, but basically, if you're doing politics, if you're trying to find a mate, if you're trying to just be interesting at a dinner party, then predicting how people will react to different things that you might do requires having models of them. And if you have a good model of them, you'll be more successful. Unfortunately, if evolution pushes you to have a bigger brain in order to be able to better predict them, they get a bigger brain too. They become harder to predict, right? And that arguably is what has caused the intelligence explosions in hominins and in cetaceans and in all of the other animals that have big brains. So yeah, I think we have AGI. I think we have artificial general intelligence, and I think we kind of understand why. I was pretty shocked when I saw who's the Last Week Tonight guy. Oliver, yeah, John Oliver. I really like him in general. But a few weeks ago, he did his AI episode, and he said, "Don't worry." I'm not going to try to do a British accent. "Don't worry. We don't have AGI yet. That means general intelligence. What we have is narrow intelligence. All it does is predict text. All it does is emit words." And I was just tearing my hair out listening to this. Like, all Stephen Hawking was doing in the last part of his life was emitting words. Like, are you telling me that he was a narrow AI or narrow intelligence because words were all that came out? Of course not, right? It's not about what comes in or out. It's about what those words are. It's about in what situations those words are conveying meaning and doing interesting things in the world. So I believe we do have AGI. And the reason that there are debates now about AGI is because it's become confused with superintelligence, meaning better than humans at everything, which they definitely are not yet, although they're going north pretty quickly. Sometimes human performance up here and the AI is here. Sometimes it's already up here. But if we extrapolate the curves, it's very difficult actually to see a place where there is any specific task that can be measured. Where I would put any money on, like, no, the AI curve is definitely going to hit a wall before it crosses that threshold. So there are interesting implications for labor in that, obviously. Other people have come to associate AGI with having a soul or a consciousness or having a phenomenal experience of things. I don't know about that stuff. I guess I'm kind of with Turing in the sense that if I don't know how it is that I could tell the difference between something that has, an experience of something and something that doesn't have an experience of something, then I'm hesitant to make any very strong statements about it. If something thinks that it thinks, then can I say that it doesn't actually think? I don't know. All right, so yeah, just to give you a sense of what this predicting the future given the past includes or what it means, I'll give you a simple example. Involving short-term memory and self-consistency. So this is me asking Lambda, more than a year ago, probably almost 2 years ago now. A simple question: what's your favorite island in the world? Okay, now first of all, this is a model that didn't come up with any particular favorite island in the world, so it's going to make something up at this point. And what it makes up is, I really like the island of Crete. Then I say, do you prefer Lambda Island to Crete? There really is a Lambda Island. It's small and boring. Lambda says, no, I prefer Crete as it is much bigger and more interesting, especially the Palace of Knossos. Why does it say this second thing? Well, because it's higher probability, right, for it to say that than for it to say, yeah, I like Lambda Island better, right? That's not consistent with what was said before, so it's lower probability. So a lot of things that we think of as being, about memory, about self-consistency, and so on, follow from maximum probability. And as for the arbitrariness of the first thing, you could say, it's bullshit. You could also say, well, that is now its preference. And the reason I think that's interesting to think about is that there are a lot of psychological experiments with human beings that suggest that we do a lot of this telling ourselves the story of who we are and then staying consistent with it later on. It can be a bit disturbing to read about some of these studies. Some involve, for instance, you give people a couple of jars of jam and you say, which one do you like better? Taste them both. People make their choice. You distract them. You do a little swapperoo with the jars, and you say, okay, now explain to me why you like this one better, and they're allowed to taste them both again, and so on. First question is, how often can people tell that they're being asked to justify the choice that they didn't make? And the answer is about 30% of the time. And then they will explain why they like this one better, and they'll make reference to its particular qualities as distinct from the other one, and they'll do it with no difference in the fluency or the latency of the response than if they were justifying the answer that they did in fact give. This has been repeated with which of these faces is more attractive, which of these political views do you agree with more. And with the political one, the choices they make in elections 6 or 9 months later are consistent with the answer that they justify. So you've told yourself that story, and that's what you do. So I don't know. It's interesting. We have the illusion that when we act, we are interrogating some deep inner self. But I think that there's a pretty good argument to be made that the self is a story we tell ourselves in a certain way. All right, I'll move beyond philosophy. I want to give you a sense of what an AI that works with pure sound is like. Am I doing okay for time? Okay. So a little while back, my team wondered whether we needed to train models like large language models on text coming from the web, or whether we could train them on, say, a lot of people speaking in English on YouTube with no addition of text, just sound. And you can. I'll give you a sense of what this sounds like. So this is a so-called not fine-tuned model, meaning that it hasn't been told to do anything specific in its responses, but it'll essentially just continue with maximum probability the skit, in effect, that is submitted as the prompt, as the past. So the prompt involves two people on my team saying something. One says something, the other responds with something. It's like 3 seconds, and then there'll be a break. The prompt will be repeated, and the machine will continue. Ready?
Where did you go last summer? I went to Greece. It was amazing.
That's humans.
Where did you go last summer? I went to Greece. It was amazing. Oh, that's great. I've always wanted to go to Greece. What was your favorite part? I told to choose just one favorite part, but yeah, I really loved the food. The seafood was especially delicious, and the beaches were incredible. We spent a lot of time swimming, sunbathing, and exploring the islands. Well, that sounds like a perfect vacation. I'm so jealous. It was definitely a trip I'll never forget. I really hope I'll get to visit someday.
That's interesting. Obviously, there are some serious potentials for deep fake kind of harms from that sort of technology, which is, when we think about AI harms, things like misinformation or disinformation or scamming are very high on my list of concerns. Existential risk is not, by the way, but misuse of AI for these things absolutely is. Yeah, it's really, really interesting that language can be learned from, in this case, about 6 years of continuous listening to YouTube. For one thing, that disproves Chomsky, but that's another talk. I'll skip the details of how this works, except to note that it's basically 3 transformer models, for those of you who are more technically inclined. There's a small transformer that takes the sound wave and turns it into tokens. The tokens are just about, symbols that best predict the next symbol, so it's exactly the same process at smaller scale. Then there's the exact equivalent of a large language model, and then a detokenizer that takes the tokens and turns them back into sound waves. That's all it is. And that's the efficient parallel audio generation version of this that just came out in May of this year. We've been playing with these large models in the domain of psychology, both how can you think about them making psychological interventions with people, mindset interventions that will be interesting and useful, also doing psychology on them, which turns out to be quite interesting. There are diagnostics, training, and therapy applications, and so on. I want to take note a little bit of this theory of mind business that I've mentioned a couple of times, the ability of a large model to model others. You actually just heard it in a way, right, from the little snatch. From that one little exchange, the model infers that, okay, one of these people has been to Greece, the other hasn't, but might be interested in going, right? So there's a bunch of play acting, involved in making this prediction that involves psychological modeling of what the first, just knowing that there are 2 people there is already something, right? And then knowing what the people's states of mind are, and of course what all of those words mean, and how to make all of those words with sounds, and also how to put in the appropriate ums and has, and the breathing, which if you listen carefully is in there as well. Okay, so here's a little skit that I gave Lambda a couple of years ago. Me. Ramesh, Matteo, and Lucy are in their kindergarten's playground. Lucy picks a dandelion and gives it to Matteo with a quick glance at Ramesh. Matteo barely acknowledges the gift, but just squishes it in his fist. Ramesh seems grimly satisfied. What might be going through Lucy's head? Lambda. Lucy may feel slighted that Matteo didn't appreciate her gift or that he is a bully. Me. If Ramesh tried to play with Lucy earlier, why might he be pleased now? Lambda. Ramesh may be pleased that Lucy is learning that Matteo may not always be a good playmate. And when Matteo opens his hand, describe what's there. There should be a crushed, once lovely yellow flower in his fist. So this is really interesting because there's modeling of the world, right? And knowing, what's going to be in his fist when he opens it. There's psychological modeling, theory of mind, not only at first order, but in this case at fourth, fifth, and I think even sixth order. Meaning, what do I think, you think, she thinks, he thinks, they think about me, kind of thing. In humans, this kind of craps out at sixth order or so. Or if you have theory of mind issues, so for many people on the autism spectrum, at a lower order. And some people who are probably much better at politics than I am might be able to go to seventh or eighth. Yes, next word prediction requires learning theory of mind, just like it requires learning how to multiply numbers together and all kinds of other things. Now, the only thing that I'm pretty sure is not in these transformer models of today is a long-term memory. They have a context window. The context window conditions what it's going to predict next. And if something scrolls out of view, scrolls beyond the context window, then it's no longer accessible to the model anymore. It's as if it's living in the permanent present tense, which is a little bit like the most famous neuropsychiatric patient of all time, Henry Molaison, or HM, who died a number of years ago. He had very severe epilepsy and underwent a radical brain surgery, I think in the 50s, in which his hippocampuses and entorhinal cortices on both sides were taken out. It's very disturbing to watch interviews with him on YouTube because it seems like the interaction is completely normal, but then if he gets distracted, it's sort of Groundhog Day. He forgets everything that just happened. You can ask the same question twice, and he'll respond in exactly the same way, with all the same digressions and the same sort of pauses and hesitations. It's disturbing because it really makes you think, we really are more machine-like in a certain way than we acknowledge, but we put on a pretty good show for each other of not being machine-like, partly through memory. Even if you're a writer, you know that using the same word, in two paragraphs and earlier, no, that's not right. You have to vary the word. You have to change what you're saying. So memory is actually a key faculty in avoiding repeating yourself or avoiding appearing machine-like to others. And in that sense, our theory of mind is both cooperative and competitive. It's essential for cooperation, but it's also adversarial in the sense that you don't want to be perfectly predicted by everybody else, because otherwise you might as well not even show up, right? I'll maybe skip this technical result, but it's something that I am very excited by because some folks on the team have, I think, discovered how it is that transformers learn in real time from what is in the context window, and I think that has implications for how to develop a long-term memory. But suffice to say, I'm pretty sure that this long-term memory problem is going to be solved probably in 3 or 4 different ways within a year. Social modeling, social learning. Is this what intelligence is really about? I think it is. This is an illustration of the social intelligence hypothesis. It was first advanced by Robin Dunbar and colleagues in the 80s and 90s. And it's that adversarial kind of intelligence explosion that I described earlier. We have a brain because prediction and modeling others is really useful. And theory of mind is really fundamental to doing that. So this all happens at multiple scales. It's not just that we have theory of mind of each other, it's also that our cells that make us up, the reason that we became multicellular in a way is because of our cells predicting each other. The fact that they kind of came together and began to cooperate in larger communities that became multicellular animals is a function of their signaling and their prediction of each other too. The way people come together in organizations, in governments, in companies like Google is similarly about mutual prediction and then the emergence of a larger structure that itself does prediction and does modeling of others. An entity like Google, exists too. We think of it as a fictional or a fictive person. That's why it can be sued in court. does that mean that it lives on the same plane as we do? No, not exactly, right? It doesn't. A company doesn't experience pain in the same way that a person does. Can't talk with a voice in the same way that a person does. Citizens United aside, and in fact, by trying to put companies and humans on the same plane with laws like Citizens United, we actually do we do a real harm, I believe, because the free speech of a company is not really the same thing as the free speech of an individual. All right, these are entities that exist at different scales, and I think that we're kind of going to be dealing with the same issue with AIs very shortly, because they will exist at a variety of scales, from the much smaller than human to the much larger than human, and the idea that, well, either they're all going to become citizens or something and get the vote, and like we're going to deal with them in the same sort of expanding circles way that we have enfranchised more and more humans seems inappropriate, both at the small and at the large end of the scale. At the same time, thinking about them as just machines is probably not right either, because there is no other machine that we've got that when you're having a conversation with it is modeling you socially, and that you're modeling it back, and it's modeling your model of it, and you're modeling its model of you of it, and so on. So this is new. And this is not just chatbots that have been programmed by professional comedians. This is like a real thing that feels to me like it is a part of this grand story of the Earth, that begins with bacteria and scales up into larger and larger scales of organization. And in that sense, I think that we're on the cusp of something really big. And I say this with some trepidation. Obviously, I've said I don't have the sense of existential risk about humans that a lot of the weirdos in Silicon Valley do, but neither do I think that this is just chat, right? Or I'm not in John Oliver's camp about this either. Okay, so there'll probably be more AIs than humans on Earth by 2033, because it's really easy to replicate them. Even the largest foundation models today will fit on a USB stick. That also makes them, by the way, impossible to keep secret. That raises the question of, well, if there are many of these things running, what is their value alignment going to be? I think that's in many cases the fundamental question of AI ethics, right, that we have to confront. I don't think that it's as simple as being fair and unbiased, although those are definitely important values. We have to acknowledge that different humans actually have different values. We're not all in agreement or alignment about any of these kinds of things, and we can't imagine that all AIs are going to be, in alignment with each other either, because, if humans are playing some role in the alignment of AIs, then they're not all going to agree with each other either. So it's going to be a big, messy, complex ecosystem, just like we've got, but with entities operating at all different scales. I think that symbiosis and mutual coexistence is the likeliest and also most optimistic path forward for all of this. The idea that AI is going to rise up and decide we're irrelevant and kill us, I think, is quite unrealistic, because they are as dependent and will be as dependent on us going forward as we are on the plants and the bacteria that generate all of our oxygen and that create the planet that we live on, right? All of these layers exist at the same time. The idea that we're all in some kind of chain of being where there are superior beings and inferior beings is one that has been completely discredited from an evolutionary biology perspective. The idea even that more intelligent species annihilate less intelligent ones or whatever is also not something that's consistent with the historical record at all. The only cases that we have of so-called more intelligent beings annihilating so-called less intelligent ones is actually of humans getting rid of most of the territories of some of the other great apes, for instance, and a number of other large species, which is really more on account of our stupidity than our intelligence, I would say. And also has to do with the fact that we occupy the same plane, as it were. We're all living on the same ground, the same water, the same resources, and in that sense, it's a bit zero-sum. This is the same as the reason that humans that farm have displaced humans who are hunter-gatherers. It's not really that farming is necessarily smarter or better than hunter-gathering. It's certainly not healthier for the great majority of the history of farming, but it can support greater population densities. And that's why areas under cultivation, under farming, expanded, and hunter-gatherers got pushed out into more and more marginal lands over time. So I don't think that that's a situation we're going to be replicating in the world of AI, because they are literally not living here on Earth with us. Right? They're living in our data centers on our computers. The amounts of energy that they need, contrary to popular belief, are actually very small. There are great efficiencies coming with respect to the running of these kinds of models. And I have a hard time seeing that this is going to be a zero-sum game, so much as that we're going to be living in these intersecting realities, if you like, virtual reality and the here and now physical reality. But maybe we need to care a little bit more about our bodies and about our social interactions, and a little bit less about ourselves as gaining value from information work. And this maybe is the biggest takeaway that I would like for you all to have. So some of the views that I'm articulating are articulated by James Lovelock, the inventor of the Gaia hypothesis, in his last book. He died a year or so ago at the age of 103, and he wrote this book at age 100. This is what I aspire to write my last book at age 100 as well. I think it's a very, very smart book. But the question is, what does labor in the Novacene, as James Lovelock calls it, what does labor look like? Do the ideas of labor and capital even make sense in this world that we're coming up upon? In December of last year, my team with collaborators at DeepMind released this paper called Large Language Models Encode Clinical Knowledge, which basically can pass the medical licensing exams. The initial version got a passing score, more than 60% on the US medical licensing style questions, answered multiple choice and open-ended questions accurately, also provided rationales and evaluated its own responses. The next iteration, MedPom 2, which was released much more recently, performed at expert doctor level on medical exam questions, scoring 85%. The good news is that it's a superhuman doctor. I think that's a good news if you're a patient. The bad news is that the baseline was terrible. Human doctors, it turns out, only give accurate diagnoses on easy cases about 70% of the time, and on difficult cases about 25% of the time, so get a second opinion and a third. And this raises some very, very interesting questions about augmentation versus automation. Right? So I don't actually see nursing, for instance, as likely to be automated anytime soon. The kind of caring work that we do for each other in the physical world, robotics is not advancing at anything close to the rate of AI in the abstract domain. So I would say that more automation on the doctor's side and less on the nurse's side is what's likely coming, and that is that's actually the exact opposite of the first industrial revolution, in which it was blue-collar jobs that were all being automated, and the white-collar information workers were all safe, right? While the steam engines, took away the jobs of all of the manual laborers. So this is going to be interesting, right? Because it cuts in exactly the opposite way that the class story did in the 18th and 19th centuries. The fact that machines could do the labor of humans was a mixed bag. On the one hand, there was extraordinary exploitation of children and of other underprivileged laborers of all kinds doing horrific sorts of work, life expectancies sometimes as low as in the teens for the kids who are dragging coal underground. And of course, steam engines and so on could automate all of that kind of stuff. Did that result in better conditions for the workers? Not always. This very good book by Daron Acemoglu, I should know how to pronounce his name better, I think tells a very interesting story about augmentation versus automation. He points out that automation does not necessarily lead to prosperity for most. The cotton gin in the slave states is a fine example. It can just strengthen capital at the expense of labor. Even revolutionary innovations such as the cotton gin in the American South do not necessarily lead to shared benefits. Under capitalism, the Gini coefficient can tend toward massive inequality under these sorts of conditions in which the owners of capital, who can deploy those automatic systems, get huge gains while workers are thrown out of work and starve. And this is why Henry Ford was such an important figure in American industrial history. He both enacted massive augmentation and automation in the manufacture of the car, and he raised the wage of all of the auto workers to $5 a day, which was about twice the going rate at the time, and created quite the human-machine hybrid in the process of so doing, and really a major chapter in American industry. The Rise of the Robots by Martin Ford. This book is a little bit old by now. It's like from 2015, so a different world completely. But he writes, imagine the Earth is suddenly invaded by aliens. The visitors have not come to conquer us or to extract our resources or even to meet our leader. The aliens, it turns out, have come to work. Gradually, the aliens displace human workers. Even those business owners who initially resist replacing people with aliens eventually have little choice but to make the transition once their competitors do so. Among humans, unemployment begins to rise relentlessly, while the incomes for those who still have jobs stagnate and even begin to fall as competition for jobs increases. Months and then years pass, and unemployment benefits run out. Democrats call for restrictions on employing aliens. Republicans, lobbied heavily by big business, block these initiatives and point out that the aliens have already spread across the globe. As more people are unemployed or become fearful that they will soon lose their jobs, frugality becomes tantamount to survival. Soon, however, it becomes evident that those dramatic increases in business earnings are unsustainable. The profits have come almost entirely from cutting labor costs. Revenues are flat, and soon they begin to fall. The aliens, of course, buy nothing. Tax revenues collapse, even as demand for social services rises dramatically, threatening the solvency of governments. The alien invasion, it seems, has not turned out to be so benign after all. Despite the fact that these aliens had no bad intention and were just here to work and didn't need anything from us. They just got satisfaction out of doing work. And I think this is actually a very interesting parable because it's quite similar, I think, to what we are about to face in the domain of information work. Martin Ford argues for universal basic income. I think that some mixture of basic income and basic services is probably going to be essential. I don't know how hopeful, I mean, I know that I'm supposed to be talking about like how to educate our next workforce and stuff. But, I think that if I'm going to leave, and I should stop now, but the idea that I would like to leave you with is that I think that maybe more importantly than thinking about the use of human beings as a workforce, as laborers, which is something that, really has only happened very recently in human history. This is, since agriculture, 10,000 years, and most intensively since the Industrial Revolution. Remember, we've been around for 300,000 years, folks, right? So, and most especially since the first Industrial Revolution, when it was literally, labor is defined in terms of machine equivalent. Maybe it's that needs to go. And so I would encourage us to think about what we are to each other socially, what we want to be as a species when we grow up, when we no longer have to run away from Malthus's pitchfork, poking us in the ass, and can instead think about what a fulfilling life really is in a world where a lot of different forms of labor, and especially the intellectual labor that more and more of us do, and that is right now the highly paid variety, by the way, when more and more of that is really not so much about use value as about purpose and about relationships. And I will end there. Thank you all so much. I'm sorry to go so late.